All right, this is Algebra 2, and we are on Chapter 5, Lesson 8, 5-8. That's where we are. It's 5-8, and that's either page 173 or it's page 179, depending on which textbook you have. Right, so we're either page 173 or 179, okay? And so what the effort has been here in our text is to just take us through some kind of abstract scenarios of dealing with fractions and different ways we might think about working with fractions in expressions and equations. So now, starting with 5-8, we're going to look at problems, word problems, story problems, word problems, story problems, that involve fractions. Okay? And so the lesson itself gives a couple of examples, and I would suggest you look at those examples and work through them. I guess it gives 3 examples. Follow along with their solution and talk to yourself about the examples and talk to yourself until you understand the steps that are being followed. What I'm going to do is just work through some of the problems in the problem set for us to talk about strategies. All right. Sorry, I had to pause there and restart my whiteboard here since it refused to cooperate. So what did we say? You are either page 1. Well, let me just give your assignment. So your assignment is either going to be 174. I've got to get this figured out. It's so frustrating. 174 to 175. Or it's just going to be page 180, right? So whatever your page number is, you're either 174 to 175. It's the 5-8 lesson, and you're going to be doing numbers 1 through 15 odd. And then you're either going to be at page 171 or 176, and you need to do number 10. Okay, now we're going to just use some of these work through some of these problems here as example. I think the examples in the text are really sufficient for you to see a variety of types of word problems and the strategies that are used. But maybe I don't confuse you. Maybe I help you if I talk through a few of the different types of problems. All right. So we're just going to start with number 1, and then I don't know, we'll figure out what to do from there. Number 1 says, in the Saturn series, the length of the C5 rocket is 175% that of the C1. Together, the lengths of these rockets total 550 feet. How long is each rocket? Okay, so the first thing I do when I read a word problem is read the question so I make sure I know what is being asked for. And it says, how long is each rocket? So what are we looking for? The length of each rocket. Okay, the length of each rocket. Now, it's important to know what's being looked for because that's going to help you establish your let whatever. Okay, so I'm going to say let x equal length of C5 rocket, and I'll let y equal length of C1 rocket. Okay, so now I know what my variables represent. Okay, now I'm going to go back to the beginning of the word problem, and I'm going to see if I can build equations from the sentences. In other words, we're going to involve ourselves in translation. We're going to translate from the English to the mathematics. And it says, in the Saturn series, the length of the C5 rocket, the length of the C5 rocket, that's x, that's equals 175%. I'll go ahead and write it this way for now. 175%. That of means multiplication. And generally speaking, whenever you're given a percentage, is going to be multiplied to something. I mean, that's just what percentages do. They multiply to things. 175% that of the C1. The C1 is y. So x equals 175% of y. Okay? The second sentence says, together, the lengths of these rockets total 550 feet. So if I take the length of the C5 and I add it to the length of the C1, that will equal 550. Well, why don't you write 550, Mr. Barrett? I think I will. Oops, I think I will. There we go. 550 feet, okay? Now that first equation, now that I see what I've got here, I could go ahead and change that to 1.75. If you don't understand how 175% can convert to the decimal 1.75, with your parents' permission, look it up on YouTube, how you convert percent to decimal, okay? Also, if you're ever unclear about that, you can typically, on a calculator, if I bring this calculator up here, if I do 175%, it turns it into decimal 1.75, okay? By the way, if I haven't said this before, I think I did, but I'm okay with you using a calculator to carry out operations here. In some cases, it only makes sense to use a calculator, depending on what you're being asked to do, but I'm okay with using a calculator, okay? Now, that is always submitted to what your parents' position is, right? If they're adamant that you don't use a calculator, then you don't use a calculator. If they're okay with it, then I'm okay with you using a calculator. Okay, so x equals 1.75 y. Now we see we have two equations. I'm going to clear this first one out just so that it doesn't confuse us. We have two equations. We have two variables. Well, you know, I don't even think I need to go any further with that one. I think you can solve it from there. Now, here's what we did, though. Or here was my process. First thing I did, step A, I decided what is it that I'm looking for? What is the question? What are they asking me to find? Part B, then. What things do I know from the, how am I going to set up my variables? What are my variables going to represent? And then part C, translate the English into the mathematics. If you always think in those terms as the pattern to follow, I think you'll always be able to do something. Now, you may not always get to the correct answer, but I think you'll always be able to do something with a problem, and you won't have to just look at it and say, I don't know anything to do. Because oftentimes, if you can stop trying to think about, well, how do I get to the final, what I actually have to do to get to the final answer, and you'll just think about, what's something I can do to start, then other ideas will come to you about how to solve the problem, okay? So the assignment is 1 through 15 odd. Let's go ahead and look at number 3. Number 3. A publishing company has 2 monthly magazines. News Report, which sells for 35 cents, and you always tell this is a older book, right? Because what's a magazine, right? But anyway, News Report and what magazine sells for 35 cents today? News Report, which sells for 35 cents, and Fashion World, which sells for 50 cents. Last month, the combined circulation of the two was 283,500, and the receipts were $104,550. How many copies of each were sold? Okay, so what's the first thing I do? What is it that they're asking me to find? So part A, how many copies of each were sold? Okay, so number, I'm going to use the hashtag, but I'm going to mean it for number. Number copies of each sold. Okay. All right, so let's figure out what can be what. So let's let X equal News Report, and by that I mean the number of copies of News Report. Let Y equal Fashion World, and by that I mean the number of copies of Fashion World. Now, there's actually something else that I could put down here, right? Because that means if X is News Report, 0.35X will be, fix that, 0.35X will equal, I'm going to put News Report revenue, right? So if we know the number of News Report copies and we multiply that number by 35 cents, we'll know the revenue that came in from News Report, or the receipts would be, I mean, I could have put receipts there since that's the word that's used in the problem. For example, if this publishing company sold 1 News Report magazine, X would equal 1. 0.35X would equal 35 cents. That's the revenue they would have received from that one magazine. And so we can do the same thing with Fashion World, which obviously is a more sought after magazine, a magazine in higher demand. And so it's 50 cents, so 0.50, or we could have just done 0.5, not X, Mr. Barrett. 0.50 Y equals Fashion World revenue or receipts. Okay, same concept. They sold 1 Fashion World magazine. Y would equal 1. 0.5 times 1 would be 0.5, and that would be the revenue received from Fashion World. Okay, so now we've done part B. We know what our variables stand for. Plus, we've got we know what our modified variable stands for, right? So let's go to part C where we translate. What do they tell us? The combined circulation of the two was 283,500. That means if you took all of the News Report magazines, the X, and added it to all of the Fashion World magazines, the Y, it would equal the 283,500. Okay? So there we translated that first part of that sentence into the math. And the receipts were $104,550. So something equals 104,550. Okay. What was that? The receipts or the revenues, right? So if you take the revenue of the news report magazines, 0.35x, and add that to the revenue of the fashion world magazines, that's 0.5y, it equals 104,550. Now look at that. We've got two equations. We've got two variables, so you can solve, okay? I hope you see the process we followed in setting up those equations and getting ourselves in a position where we can solve this particular word problem. We figured out what it was that we're looking for, number of copies of each sold. So we let our variables stand for the copies of each that would have been sold. But from that opening sentence, we also realized that we could determine, if you will, the value of each copy, right? And that led us then to the ability to set up two equations. Whenever we have two equations and two variables, we can solve. All right, so that's number 3, and I'll let you finish that. By the way, don't, it would be unfortunate if all you did was just pick up from where I'd stopped and you solved the equation, right? Now, if you followed how I set it up and you truly understand how to set it up, perfect. But if you didn't, if you're not sure you know how to set it up, then, I mean, if you want to pause this video, audio, whatever, and work through the problem, then do it. Talk to yourself about how you set up the problem so that you understand what it is that you're doing. And then you can know that you are on your way. Okay, so let's look at number 5. Let's look at number 5. Number 5 says the average of two numbers is 15. Find the numbers if the smaller is 2/3 the larger. Okay, so this one just dives right into sentences that we could translate, but we can still think about our process. What are they asking us to do? They're asking us to find two numbers. Okay, now that last sentence actually says find the numbers, but from the first sentence I know that it's two numbers. Okay. All right, so let's declare our variables. I'm going to say let x equal smaller number, and I'm going to let y equal the larger. Okay, now why did I say that? Well, in that second sentence, that's the way they identified the two numbers, characteristics. One's smaller, one's larger. Okay? All right, so let's see if we can build some equations. Now, it says to me in the first sentence, the average of two numbers is 15, right? So let's think about how we find the average. To find the average, we add the numbers together and we divide by the number of numbers, right? So we have two numbers we added together, so we divided something by 2 and got 15. Now, if I wanted to, I could set this up as x plus y divided by 2 equals 15, right? But very quickly, I could see that that becomes x plus y equals 30, and I like that equation better than the equation with the fractions. Okay, but I guess we're supposed to be using fractions. Um, anyway, now that I think about it, problems involving fractions. I don't think I've used a fraction yet. Well, I guess out of decimals, right? And decimals are fractions. Okay. Every number's a fraction. But anyway. Okay, so what does the second one say? Find the numbers if the smaller, that'd be x. So if the smaller is 2/3 the larger. What does that mean? Well, if you take 2/3 and multiply it to the larger, now we got a fraction involved. Okay, so once again, I've got two equations. I've got this equation right here, and I've got this equation right here. Two equations, two variables I can solve, right? And when you've got two equations, two variables, remember, you can use, you could graph if you want to. It's probably not the best choice. You can combine the equations and try to lose one of the variables, or you can substitute. This one looks like it's ripe for substitution, since x does equal 2/3 y. Okay, I'll let you complete that. Hopefully you are understanding the process for setting up. These equations. Okay, so when I look at number 7, I think number 7 is similar to example 1, so I'm going to leave number 7 for you to, if you need help setting it up, follow example 1. I think you're going to find that they are similar. These types of problems are called work problems. Oftentimes it's one person can turn out so many in so much time, another person can turn out so many in so much time, that sort of thing. That's the idea. Number 9 looks like a looks like a distance equals rate times time problem, I guess. We've got a rate of walking at 3 miles per hour, returning home over the same route by bus at 12 miles per hour. He wants to spend just 2.5 hours for the entire trip. Find the greatest distance he may walk. Let's think about that one for a minute. So what are they asking me to find? Find the distance. So what do we know? Well, we could say let d sub w equal distance walk. D sub b equals distance bus. Okay, so since we know that, that would tell us that the distance walked equals the rate walked times the time walked. The distance bused equals the rate bus times the time bus. Okay. The question here is find the greatest distance he may walk. Okay. But whatever distance he walks, the distance walked has to equal the distance bust. Right? That's the only way he's going to be able to get back home. Okay? If those distances are the same. Right? Because if he walks farther than he's bust, then he can get back to home. So these distances have to be the same. That means that the rate walked times the time walked has to equal the rate bust times the time bust. Okay? So what is the rate walked? Well, the rate walked is 3 miles per hour. The rate bust is 12 miles per hour. And the only other thing we know is that if we add the time walked plus the time bust, it equals 2.5 hours. Now, frankly, with that information, you should be able to solve this problem. Okay? And what did we do? We determined what it was that we needed to find. I let d sub w equal distance walked, d sub b equal distance bust. And then I just remember that distance equals rate times time. So I set up a distance walked equals rate walked times time walked. Distance bust equals rate bust times time bust. But I also then realized that the distance walked in this scenario is going to have to equal the distance bust, because he's going to start from home, he's going to walk a certain distance, he's going to get on the bus, and he's going to go back home. So the distance he walks away from home is going to equal the distance he buses back to home. That means the rate walked times the time walked has to equal the rate bust times the time bust. Okay? This particular distance problem is a distance 1 equals distance 2. Okay? Okay, so how can we then solve it? Well, I can put a 3 in for the RW. I can put a 12 in for the RB. But then what? I've got TW and TB. Now, TW and TB don't equal each other, right? I mean, if you're walking 3 miles per hour, it's obviously going to take you longer to walk the same distance that you would cover if you're on a bus and you're going 12 miles per hour. How do I know? Well, in 1 hour on a bus, I could go 12 miles. Walking at 3 miles per hour, I'm going to have to walk for 4 hours to get to 12 miles, right? Okay. Okay, so what could I do? Well, this equation right here, what if I were to rearrange it this way and say that the time walked equals the 2.5 total hours minus the time bust? Oh, well, that's interesting. I could substitute this for this right here. And so I would end up with an equation that is this: 3 times 2.5 minus TB equals 12 times TB. And now I have one variable in one equation. Okay, I went too far with that, but that's how I would get it set up. You can solve from there. Number 11 is actually a distance equals rate times time, right? There's a very short amount of time, 0.0015 seconds, 0.01 seconds. There's a very short distance, 7 inches. But just remember, distance equals rate times time. So I think number 11 is doable. Number 13 and number 15 are the same types of problems. I want to take a look at number 13 and set that up because it's a common type problem that is presented. We call it a chemical solution problem. So let's take a look at this. An aftershave lotion contains 50% ethyl alcohol. How much water must be added to 6 fluid ounces of this lotion to reduce it to one which is 75% non-alcoholic? Okay, so this is number 13. So again, let's start with the question. What are they asking me to find? Well, they're asking me to find how much water, and so I think it's going to be ounces of water. At least fluid ounces was used in the ounces of water to add, we'll say. All right, so let's do this. Let X equal ounces, OZ for ounces, right? Ounces of water. Okay. So what do we know? Well, we know that, and setting these up, I like to use something of a diagram here. We know that we have 50% alcohol, but if it's 50% alcohol, it's also 50% water. Okay, so I'm going to say this is 50% H2O. And I'll explain why I chose that and didn't call it 50% alcohol. It says how much water must be added to 6 fluid ounces. So we have 6 ounces of this solution that is half ethyl alcohol. So it says how much water must be added. So we're going to do plus. So if we're adding water and the solution that we're starting with, or the lotion that we're starting with, is 50% water, this would be 100% water. And we're wanting to know how many ounces, so that's our X, to get, to equal, to reduce it to 1, which is 75% non-alcoholic. Right? So that's why I chose H2O, because the final solution here is 75% H2O. Okay, it's only 25% alcohol. Now I could have used the alcohol, but, well, I guess I could have, but it'd be better to use the water also, because if I used alcohol, then this would be 50% alcohol, 0% alcohol, 25% alcohol, and 0% alcohol would be a problem. Okay. Now, notice what we have here. We could say we have the quality of the solutions, right? The quality of that first solution is 50% water. The quality of that solution we're adding to it is 100% water. The quality of the final solution is 75% water. And then we have the quantity. Right? The quantity would be 6 ounces. X ounces. Well, wait, what's the quantity of the final solution? Well, the quantity is 6 plus X ounces, right? The 6 ounces of the 50% water and the X ounces of the 100% water. Now, this concept of quality quantity is something that you will return to regularly in problems. In fact, the publishing company, problem number 3, that was really a quality quantity. Right? The quality of the news report is 35 cents. The quality of the fashion world is 50 cents. Right? The quantity was what we found of each, the quantity we found of each, right? So those types of problems, coin problems, where you got a certain number of coins, some are nickels, some are dimes, right? The nickel has a quality of 5 cents, the dime has a quality of 10 cents, and then there's quantities of each. So it's thinking in terms of quality and quantity, at least in my mind, is a really helpful way to approach a lot of different problems. Okay, so how does then this work? Well, for each term in this kind of equation, you always multiply the quality by the quantity. Okay, so we would say 0.5, that's 50%, right, times 6, there's quality times quantity, plus 1, 100% is 1, times x, 1x, equals 75%, or 0.75, times 6 plus x. Notice in every case here, across the equation, it is quality times quantity. Okay? And so now you simply solve that for x. And what is the x going to tell you? Well, it's going to tell you the ounces of water. Is that going to answer the question? Yes, it will. All right. And so number 15, you should be able to set up in a similar fashion. Okay. Now a little bit tricky part about number 13 was the first thing they told us about was something that's 50% ethyl alcohol. Okay. So keep in mind what they tell you and what it is that you're the qualities of the other parts to the problem, right? So the quality here is pure water. The quality here is 75% water. So that 50%, turning it into 50% water is the smart way to go. Okay? Number 15, similar type problem. It's a solution problem. And so you should be able to follow that same process. Now, I think, their example 2 is a solution problem. And I mean, you can look at their example and maybe it will make more sense to you. It's a little bit unique because it is at least 72% alcohol. So they did a greater than or equal to, but still, you can look at their example and it might make more sense to you. Maybe mine makes sense to you and you can do that. Okay, so you're doing numbers 1 through 15 odd on either page 180 or pages 174 and 175. And then either page 176 or 171, you're doing number 10. And number 10 is simply, again, working with fractions, right? So that number 10 problem is this: 2 over 1 equals 3/2 x squared plus 26 over 3 x. Well, remember, when you've got fractions throughout the equation, go ahead and multiply by a common denominator. If it were me, I would multiply everything by 6. And that'll eliminate the fractions, and then you can go about solving as you know how to solve. Okay? All right, so that's 5-8. Hope that makes sense. And you have your assignment right there. 1 through 15 odd for 5-8. That's either page 180 or pages 174 to 175. And number 10 on either page 171 or 176, right? So you're either this set of pages here or you're this set of pages here doing these problems. All right, enjoy.